We are absolutely delighted to hear the news about MTPConnect deciding to invest in the important area of 3D bioprinting. We will be accessing these funds in order to develop new and exciting commercially relevant projects. These include the development of the BioPen with SMR Automotive and St Vincent's Hospital in Melbourne, the iFix pen for corneal regeneration with Sydney Eye Bank, and also developing new and exciting processes to extract biomolecules from seaweed for 3D printing with Venus Shell Systems. And I'm speaking now with Dr. Per Winberg. So the two biomaterials from seaweed that are most commonly used at the moment are alginate and ulvan. Alginate 3D printed for applications like muscle cell regeneration, and ulvan 3D printed for wound healing. Can you tell me specifically about those two types of biomolecules?
Well, seaweeds have lots of exciting gels in them that do different functions in the actual seaweed themselves. And the alginates come from the category of brown seaweeds, the big kelps. And you can imagine being a big kelp in the ocean is that with waves and flowing around, you need strength and flexibility. And that's what alginates can offer. And they also maintain a moisture environment. Whereas some of the molecules interspersed in the seaweed are important for connecting to the actual seaweed cells. And then there's other gels that do that. And in the green seaweeds, what's exciting is that the gels that connect the cells are actually gels and signatures that our skin cells recognize. And so that specific gel is better for cell connectivity and binding. And so these two gels together, for example, in a formulation could deliver both strength, flexibility, and cell connectivity and function.
So there's obviously a great opportunity here for a brand new manufacturing industry in Australia, which is all about taking biomolecules from seaweed specifically for making bioink formulations.
Oh yeah, because we now have one of the few controlled sources of seaweeds from the actual genes of this very unique Australian seaweed, we know that we can now start to scale up production. At this stage, a production of the actual seaweed of 4 tonnes dry weight in a year. And we could actually produce about 100 tonnes of that seaweed on a hectare of land. If you compare that to wheat or other sources of farmed products, that's 20 times faster. So and the molecules we're extracting for bioprinting are between 20 and 40% of that biomass. So that's about 20 to 40 tonnes of these molecules on a hectare of land. That must be by far one of the most fast and efficient production systems.
Best molecular factory in the world.
Best molecular factory in the world, for sure.